I welcome you once again to another video session on Math 302. So in this video, we are going to consider the rank of a linear mapping. And as well, we also need to consider this concept, which is bilinear form and quadratic form as well. So those are the three things that we need to consider in this video session for series 4. So we also have. Okay, let me write it out. We want to consider the rank of a linear mapping. That's the first one. And at the same time, we want to consider the bilinear form, bilinear, and we also have bilinear and quadratic form. Let's put it that way. And quadratic form. So those are the three things that we need to consider in this video session. So now let's start with the rank of a linear mapping. So take for instance, if you have been asked to find the rank of a linear mapping, you're familiar with a linear mapping now, whereby you be given a linear map. Let's say you're given a linear map of phi, that which is defined by let's say you have R3 into R2. Okay, so you know that this linear map will be surely defined to you. Maybe x comma y comma z is equals to something. Okay, whether okay you have three, then you're expected to have something like, let's say you have x plus y here, and let's say you have 2x minus y. So whatever you have here is what we call a linear mapping. Looking at it this way, use a linear mapping function in this case. So you have linear map phi of xyz projected to x plus y and 2x minus y in that case. But for the sake of the example that I want to use in this case now, let's try this question, which says find the rank of the linear map. So when you hear the word linear map, you know what's going to follow. So let's say we are given a linear map phi. In the question, we're given a linear map phi, okay, which is defined by, okay, in this case now we now have R3, we now have R4. Haha, this is not something that is really easy to work with, but it's still simple. So R4 maps to R3 in that case. So where we have it to be defined as thus. We are not using X, Y, Z this time, we are using A, B, C, and D. That's what we have. And then this is R4 maps into R3. So you have four different um variables here, such that I'm very sure that I'll have like three coordinates here. So I should have something like A, okay. In the question, we have this as A plus 2B minus C plus D. That's the first one. I have this maps into R3. So I also have another one again as minus 3A plus B plus 2C minus D. And the last one, which is given to us as minus 3A plus 8B plus C plus D. Now we need to find the rank of this linear map. Just the rank, not that. Okay, we also just find the rank of this linear map. And to do that, it's not something that is really like that. Let's go ahead with the solution. So the first thing you need to remember is you need to find that matrix A for the linear map. So how will you look for matrix A? The matrix representation of linear map. A matrix A is actually what we used to refer to as the matrix. You need to look for the matrix representation of that linear map. Representation of linear map phi. So how are you going to look for that? So to look for this linear map now, the matrix representation of linear map phi. So how will you look for A? I've actually explained something like this before. To look for matrix A, so in this case, the not really states that you should find matrix A with respect to the standard basis. So you don't need to show any workings for standard basis here. You don't need it. Just go ahead and use that my short method I told you, and then go ahead and find the rank of the linear map. Just two steps that you are done. Okay. To find matrix A now, I'm not. It was not. It is not stated in the question that I should find matrix A with respect to the standard basis. So I'm free to just transform. I just need to do a little linear transformation here such that I have a linear a linear expression given to me. So I have to express it in a column vector matrix. So if I want to do that now, this is in row format. So let me write it out in a colon format, whereby I'll have this first one as a plus 2b. I believe you are familiar with this. I've done something like this before. And I also have this as minus 3a plus b plus 2c minus d. And this third one, I have it as minus 3a plus 8b plus c plus d. So that's what I have. So what I need is the matrix representation. As I said there, we need just the matrix representation. That will be what is, we have the complete as A, B, C, D. So I only need their coefficient to get the matrix. So the coefficient of A here is 1, the coefficient of B here is 2, the coefficient of C is minus 1, and the coefficient of D is 1. So I'll do the same thing for the rest. This is minus 3, 1, 2, minus 1. Just their coefficient. And make sure you try to avoid any form of any mistake. But if you okay, so now this is what we have. Now, since we have gotten our A as 1, 2, 2 minus 1, 1, minus 3, 1, 2, minus 1, then minus 3, 8, 1, 1. So then we now need to find the rank of that matrix. That's all. Find the rank of the linear map. So before you can find the rank of the linear map, you need to find the matrix representation for the linear map such that you now end up finding the rank of that matrix for that matrix representation. So now let's look for the rank of matrix A. Okay. Now to look for the rank of matrix A now, what are you going to do? To look for rank of a matrix, we need to, do you still remember math? In linear algebra, we have what we call, you can actually resolve a matrix to row echelon form. I don't know whether you remember that. So we need to express this matrix here. We need to deduce it to a row echelon matrix. And for us to do that, a row echelon matrix will tell you that you are expected to, okay, if I were you, what I'll just do is I need to identify the left right diagonal starting from this first digit here. So I'm going to detect the left right diagonal here. Okay, so whichever any value that you have that falls under this, you need to express it to zeros. So that means the upper triangular matrix I have here now is just minus 3, and 8. So you look for all means to turn this minus 3 to 0, look for all means to turn this one to 0, and look for all means to turn this one to 0. So just 3 digits here. Just try and use row reduction method to reduce this to 0, find all means to turn this one to 0, and find all means to turn this one to 0. You've done that in math 202, that's linear algebra. So let's say you have, but at first, what I said was you need to identify your left right diagonal first. So any other digit you have on that falls under this line, you have to turn it to 0. That's the best way to quickly recall what row echelon form means. So let's say I want to give you another format whereby, okay, let's say we have a matrix of this form 2, 3, 6, 5. Let's say you have 4, 3, 1, 6. Can you reduce this to row echelon form? Yes, you can. So just take this first digit now and then identify the left to right diagonal like this. So which value are you going to turn to 0? Only this 4. You need to find a way to turn it to what? To 0. Then that's all. So what if you have a 3 by 3 matrix? Let's say you have 3, 4, 5, 1, 2, 6, and 3, 2, 7. So if you want to reduce this to row echelon form, what will you do? Identify the first digit here, okay, and then cross out the left to right diagonal. Okay, that means 327, right? It's gone. So any other letter that falls under this line, that is what you need to turn to 0. Turn this one to 0, turn this one to 0, turn this one to 0. So I think I've tried my possible best to explain, to give you a recall on how row echelon form works. So how will you turn this minus 3 to 0, this minus 3 to 0, and this 8 also to 0 as well? So it's not something that is really easy to work with, but let's try to check whether we can play around that. So you must be very, very familiar with what we call the rule reduction form. You must know how to do this rule reduction. You must know how to find the computation of rule reduction method. So now look at this. I want to turn this minus 3 to 0. I want to turn this one to 0. So this is what I used to do. I used to consider it colon by colon to know which one. You don't just pick it anyhow. As for my own method, if you turn this one, if you want to do this one, if you want to turn it to zero, and then you might end up saying, okay, the next one I want to do now, I want to go and turn it to zero. I don't do it that way. I used to follow it colon by colon. Okay, I used to follow it. Okay, I'm taking this one first. The next digit is this one. So then I'll go to the next colon. Okay, the next digit is I have to turn this one to zero. So take it one after the other. So now these are our main targets. This minus three. I want to turn this minus three to zero, and that means this minus three now is already on row two, right? So what are you going to do? How can you actually turn this one to zero easily? So there is a particular general formula I used to use, which you must always follow. So that formula is simply implies I want to clean this part. I want to clean this part. Okay. So now looking at this, pay full attention. I want to turn this minus three to zero. So whatever you just have to do now is to go ahead and write, okay, this minus three is on row two. Write it as minus three. Okay. Then plus, okay, plus. Always write whatever you want to turn to zero. Write it. This thing here. Write it out first. Then plus. Now, let's say you have to is a must, like just use this. This is like just like a pattern that you must follow. It works all the time. Okay. Then when you write plus, always make sure that you put x here, standby. Make sure that x is there, standby. Then you open a bracket. Then you say is equals to what is our aim? Our aim is to turn this one to zero, equal to zero. This is just the pattern. This is a general formula to use most of the time. I repeat, what you want to turn to zero, write it out. Then plus alphabet x. Then after writing plus alphabet x, then the next thing for you to do is to go ahead and put a bracket here, then equal to zero in that case. So what are you going to do from here? So when you look at this clearly now, this minus 3, I've written it out. Any other digit that comes below it, you are not expected to put it here. Whatever you have here, you are expected to relate it with what you have above. Okay? What you have above it. Do you understand? So, and take note, most of the time you might end up having, if you have zero here, then there's a way you have to go about it. I think in linear algebra, we used to subtract the first row and the second row. Subtract the second row from the first row so that this part will not give you this zero part, this zero. Okay? But since you already have one here, I repeat, just write this first, then plus x. So this first digit, I'm not interested in the lower part, just the upper part. Okay, just the upper part. So now that I have one here, so this one comes into this bracket and then solve for x. So if I solve for x here trivially, I will surely have my x to be equals to, when this one goes like this. So I just want to do that one somewhere else. Okay. If I want to solve for x here now, then x is equals to 0 plus, when this minus 3 goes like this, I have 0 plus 3, and that's 3. Since my x is equals to 3, then you've gotten your value for x. Then this is what you just do. Okay, this minus 3 is on row 2, right row 2. Then plus, what is your x? Your x is 3. This your 1 is from where? You pick it from row 1, right? You are dealing with row reduction method. So now, this one I just I pick it from row 1. So then you write row 1 in this bracket. So if you go ahead with this expression here, this row reduction method there, I'm very sure this one will turn to zero directly. Now let's confirm. I did not touch this first row at all. So what I'm interested in is to turn this particular part to zero. And then the formula is that, okay, you write the formula here. So this, what I have here now is what you just come and put it here. Row 2 plus 3 row 1. You might not really understand what I've done here until I try another one again. Until I try another iteration again to you grab. So just hold on. So I already have this formula here. Row 2 plus 3 row 1. Oh yeah, let's confirm. Row 2 is, I want to get this result here. Row 2, at this point I have minus 3. So if I put minus 3 here, then plus 3, then times, what's row 1? The digit at this position, the digit I have on row 1 is still 1. So if I add this one together, minus 3 plus 3, and that will give me 0. So I already automatically I have 0 here. Done. And that's our aim. That's turned to 0. Now what will happen to this one here? The same procedure also. At this position 1, okay, what am I going to put here? So then you now come here. You are using this general formula here. This is what you are using. Okay? This is the row reduction method you are using. So I have my row 2. This is the formula here. I want to do my workings under this part. So my row 2 here is 1 now. I'll write 1. Okay? Then plus 3 times row 1. At row 1 on this position, I have 2. So solve it out. What are you going to have? So that's the logic. 1 plus 3 times 2. That's 1 plus 6. And that's 7. So then I'll come here and write 7. Are you flowing? So the next thing now is for the next digit. At this point I have 2. Okay? And at this point I have minus 1. So my row 2, I have it as 2. You write 2. Then plus 3 times row 1, I have it as minus 1. So solve this out. What are you going to have? 2 minus 3. And that is minus 1. So you come here and write minus 1. So how are you going to get this digit here? It's from the relation of this row 2 and this row 1. So row 2 now is minus 1. I write minus 1 here. Plus 3 open bracket. Row 1 here is 1 at that position. Then you have that as minus 1 plus 3 times 1. And that is 2. That's minus 1 plus 3. That's 2. So then I'm done with this row reduction method. This is done. So how are you going to get the formula for this one too? Similarly, what I've done here is what you also do for this point here. Okay? So you also do for this. Now, do you know that I've already turned this one to 0? So I'm only left with just this part. So I want to turn this one to 0 next. So that means I can actually relate this and the first one. You can't relate this and the second one. Please take note. Since I've already used this part. That's why I say you must follow it in order. So immediately when I turn this one to 0, and then you now want to look for the one to relate. Try to relate this third one, this last one, together with the first one. Okay? So that's how it works. Hello? How far? No, I'll call you back. I'm praying. I'm praying. I'm praying. Alright. So in this case now, I only have choice that to the only choice I have now is to relate this third row and this first row. Please take note. So now let's check. Based on this same pattern, so I believe I can actually clean this off. So let me clear it. Let me clear this off now. Let me clear this off so I can have space to do the row 3. Now let's see how this one works. For this part now, I want to turn this minus 3 to 0. Also write it as minus 3, then plus, then x, then times. I can't relate with this one. I can only relate with the first one. 1 equals to 0. So we still have it as the same because I have the same result here. That's why. So I will still have my x as 3. So then if I solve for x now, x will still give me this 3. So that means I automatically have this minus 3 here now. This minus 3, I pick it from row 3. So I'll write the formula as row 3, then plus the x I got is 3 from up here. And the one I pick is from the row 1. Okay, I can't use this. I already told you because I've already used this before and that's turned to 0 already. So I'll pick row 1 equals to what? Okay, I think that is equals to whatever you have as that result in that case. So just come here and write out the formula. Okay, the row reduction method I want to use here is row 3, then plus 3 row 1 as well. So I believe you might not really understand it yet until I try this one. I think you usually get it when I try to. You get this my pattern when I try this. If I want to turn this one to 0, I'm very sure you get it clearly. So what's row 3? Let's start with this minus 3. You know that this one will usually give us 0. This one will be minus 3 plus 3 times 1. I'll have it as 0. And as for this case now, if I have 8, in this case now I have 8. So for this one now, I have 8 plus 3. What is the row 1 value? At this position, the row 1 value is, at row 1, I have the value as 2. Okay, as 2. So that will give us 8 plus 3 times 2, 6. And 8 plus 6, that is 14. In that case, so I'll just come here and write 14. So the next one is, I have 1 now. So what is going to be the value? At this position, row 3 is 1. Okay, at the same position, row 1 value is minus 1. The corresponding row 1 value is minus 1. So if I add this now, that's 1 minus 3 and that's minus 2. So I'll do the same for this last one. At this position, row 3 value is 1, then plus 3 times row 1. At this position, the value is 1 up there. I think if I add this one now, I'll have it as 4. So I have 4. So now I have 0, 0. Looking at this left right diagonal now, it's only this 14 now I have to turn to 0. Okay, so what are you going to do from there? Successfully, this has I've been able to turn this one to zero. So the last thing is to turn this 14 to zero. Okay, how did I know? If I draw the left right diagonal now, I need to consider this last part. And I said all the values you have that falls under this line, you must turn it to zero. That's what we call resh. That is resh in our form. Is that clear? That is the upper triangular matrix. When I say upper triangular matrix, this is what it means. Okay, this forms an upper triangular matrix. See, Tabi now, if I cut this now, just this part, let me double it out. See, it forms a upper triangular matrix. This is lower triangular matrix. Whatever I have here is lower triangular matrix. Do you see that? This is lower, okay? This is upper. So that is just the basic concept of it. So let me take that off. So my aim now is to turn this 14 to 0. And how did the pattern I explained, how did I derive this? I actually said, okay, I want to turn this 14 to 0. Write out 14 first, okay? Then plus, I asked you to put letter X. Then open a bracket. Then our aim is to turn this 14 to 0. Please always remember this part. This is the best pattern to use. I will not lie to you. Okay, so what are you going to put? What are you going to put here? So in this case now, I don't know, is it 7 or is it 2? That's our main target now. Do you understand? If I relate, okay, I've already used 14 abi. If you go ahead and relate this 14 here, if you want to look for the value to put inside this bracket, if you go and use it as 2, that means you're already relating row 3 and row 1, which will automatically affect this 0 and 1 in the operation. Because 0 and 1, I think this one will change back. This 0 will now go back to another value like 2 or any other value. So you are not advised, it's not advisable to relate this with 3 and 1. Why? Because if it will actually work for this and this, whereby it will successfully, I'll be able to turn this 14 to 0 if I relate this and this. But it's going to affect this 0 and 1. Okay. So like I said, looking at this now, since I already picked 14, I'll just pick the next value on it. That's all. That's the best way. If you follow the pattern I said, colon, turn it first one, second one. If you follow it that way, it will surely work most of the time. And if it doesn't work, if you notice that it doesn't work, make sure you are always related. Okay, I want to relate to 3 and row 2. Yeah, is it going to work? Let's check. Okay, 0 and 0. So it will not affect the zeros I already have. But if you relate 0 and 0, no matter how it is, the result, the operations, no matter how you add or subtract, you still end up having 0. But if you can relate 0 and 1, at the end of the day, by the time you start adding and subtracting, it will change the value entirely to another thing. So I will advise you to pick this 7 so that when you want to do the operation on this and this, it will not affect. But if you go and pick 2, it will affect that 0 and 1. This 0 will change to another thing. And that's our aim. We need to turn this one to 0. And if it changes to another value again, that means you keep playing, moving forward and moving backward in your operations. So now I will have to use this one, this 7. Now let's solve for x. If you have 14 plus 7x equals to 0, what will be your x? So my x will now be equals to, my 7x will be equals to minus 14. So my x will be equals to minus 2. If you find x out, that will be minus 2. So this 14, I pick it from row 3. Do you agree with that? I pick it from row 3. Then my plus, my x value now is minus 2 after solving. My 7 is on row 2. Is on row 2. So this is the pattern you need to follow. So just come here and write out the formula here, the row reduction method. I want to use this. Okay, I want to use row 3, then plus minus 2 row 2. So that's the concept. Now let's check. So what that give us? I did not touch this one. I don't have any business with this one. I don't have any business with the second row. So I'm only interested in the third row. Now let's do our manipulation. Let's do our computations now. So for this first digit, is it going to affect? Let's check. Row 3 is 0 plus minus 2. Row 2 at this same position is also 0. So that will be 0 plus 0 times minus 2. 0 plus 0, that's 0. So I have this place as, so it does not affect. I didn't that I've already picked 1 now. I do I related with 1 and I put 1 here. That will be 0 minus 2. That's minus 2. To change this one to minus 2. And that's not what we need. We need this 0 to be fixed, so without any problem again. So now let's go with the next value, 14. At 14 on row 3, what's our row 2 value? 7. So 14 minus 14, that's 0. So successfully, you see, we've achieved our aim. So now what's the next thing for us to do from here now? At this minus 2, I have this as minus 2, then plus minus 2. I'm using this formula. Then what is row 2 value? Row 2 value is minus 1 at this position. Minus 1. So if I express this, what are you going to get? Minus 2 plus 2. That's 0. So I have this raised to as 0. But my own aim is this 3. So there's nothing that I'm not really interested in this, whether I have 0 or not. It's not all the time you have 0. But this is the fact that we want to look for a rank of A. So there's a conclusion that we used to make, which I'm still going to explain. So here I have 4. For the last digit here, I have 4. 4 on row 3, then plus minus 2, and I have row 2 value as 2 in that case. So this simply implies that I have 4 minus 4, and that's 0. So I have this one to as 0. So I think we've achieved our aim. We have been able to reduce this to a row echelon form. Now that we have this in row echelon form, you can easily know since we already have the row echelon form, then you can easily state the rank of A. So what will be our rank of A? Our rank of A is not something that is really hard. It's just a particular statement that you need to take note. And the statement simply implies that um, the members of non-zero row is what? We only need to consider our rank of A, okay? Our rank of A, the final answer is just, it actually represents the numbers, how many number of rows, how many number of non-zero rows that you have. Our rank of A is the number of non-zero rows that we have in that matrix, in the matrix. And that matrix, you'll have reduced it to echelon form before you can actually consider the rank. Rank of A, the rank of matrix A that we are looking for is actually the number of non-zero row in the matrix. When I say non-zero, that means I'm considering not that all the rows are 0. A zero row means all the rows are 0. A non-zero row means, okay, not everything are zeros, right? If I just write, okay, 0, what's the 0 row? A 0 row simply implies that, okay, a particular row that is 0 all through. That's what it means. But when I say, okay, rank of A is the number of non-zero row, that means looking at this, I have how many rows now? I have row 1, row 2, row 3. So I want to consider just a non-zero row. So this is a non-zero row. This is another non-zero row. But this one, I will not pick it because everything is 0 row. So I'm only considering the non-zeros. So this is the non-zero row. This is a non-zero row. This is another non-zero row. So how many numbers of non-zero do you have? There are just 2 in numbers. Just 2 rows that are non-zeros. So the rank of A for that linear map, phi is what? Is 2. So this is what we are looking for. Simple as ABC. So that's how it works. That's how we used to find map of function. So we have exercises. So you might end up seeing this kind of question. I think there is exercises here. The first question says find, okay, let's say the question says find the rank of the linear map phi defined by Rn into Rm. So you don't know what n is, you don't know what m, you don't know that is 5 or 4, we don't know yet. In each of the following. So we have 2 questions in that exercise. Please take note, try to solve. I will only solve one, then you can actually try the second one too. Where n is 4, they give you where n is 4 and m is 3. That means you have R4 maps into R3. And do you know the funniest thing? The second, I will not do the second one. The second one is big. That one, the second is 5 and m is 4. So this one will really take time. And this is an online video, so I have to cut it. I don't need to I don't need to let the video have a long length timing. So n is 5, m is 4. That means this one R5 maps into R4. I know what that means. It will really take a lot. But let's just deal with this. I will solve this now. So n is 4, m is 3. Just substitute it here while trying to show your workings. So what is the linear map definition? It is being defined by A, B, C, and D also as well. Okay. Then I will now have what we are given now is now 2A minus B, then plus 3C plus D. That's for one. You know it is 3. 4 maps into out 3. So I should have 3 different coordinates here. So this one I should have we are given this as A minus 8B plus 6C then plus 8D. Okay. And the last one is A plus 2B then minus 2D. So this one I will do for the sake of this class, for the sake of this video session. But you can also try this one as well. Okay, just try this on your own. So this one now we are given as this is ABCD. Why is it ABCD? Why is there no E? Because N is 4. R4 maps into R3. But when you now have N is 5, R5 maps into R4. That means I'll have this one up to 5 of them. So that's how it is being stated. So you now know why you have A to E. Understanding matters, please. Take note of that. So now that means this one I will now have 4 different, instead of having just 3, I will now have 4 different coordinates. So we have this as 2A plus 3B plus C plus 4A. It's not easy. That's the first one. The second one is 3A plus B plus 2C minus D. Please make sure you try this so that you can actually understand it clearly. 4A minus B plus 3C minus 2E. And the last one is 5A plus 4B plus 3C. Then we have this as plus 3C. So please, I want to just hold on. So sorry for that. So the last digits here is 3C plus D then plus 6E. So that's what I have. So I want to solve this A part. So for the sake of this online video session, if I want to do this again, it's going to take a lot of time. So let me just take this. So you can actually understand, have a concept of how rank of linear mapping works. So what's the first thing? So I need to write out the definition. I have this, okay? This is given to us in row. So I need matrix A. So after getting matrix A, I'll now go and look for the rank. So matrix A now is I have to express this row form to a colon vector matrix. And that is, this is 2A, write it out first. 2A minus B plus 3C plus D. The second one, A minus 8B plus 6C plus 8D. The third one, A plus 2B minus 2D. Okay? So now I don't need this. What I need is just the digit, the coefficient. And that is 2. Coefficient of B is minus 1. C is 3. D is what? 1. So I have 1 minus 8, 6, 8. 1, 2. I think C is missing here. That will be 0. And my D is minus 2. Now, what's our main objective here? Our main objective is to reduce this matrix to a row echelon form, right? Remember, so if you don't understand this thing clearly, forget about it. You'll not be able to find the rank. So, like I explained, I said you pick the first digit here and then you cross out the left right diagonal so that you can easily detect which ones you want to turn to 0. That means I want to turn this one to 0. All the digits that falls under this line, I want to turn them to 0. That is the upper triangular matrix. You express it as what? 0. All the digits you have there. So that means I want to turn this one to 0 and this one. And I notice one thing is most of the examples, why are this the same? But it does not really mean. Okay. So in some other methods, another person can decide to mix this and this together because one, they can decide to okay, row 2 minus row 3 will automatically give us 0 here. But please, let's follow the same, just have one pattern to your solution. That's it. Understanding matters. So it's not that I don't like doing it anyhow. I will still use the same procedure. Okay, now I want to turn this one to 0. Let me remove that. I want to remove this. Okay. Now let's reduce this one to zero. And what was the logic? This is my pattern. This is my first. This is the first value I have to pick, right? I said take it colon by colon. This first colon, you turn this one to zero, turn this one to zero, go to the next colon, then you have to turn this two to zero. That's the logic. That's the concept, rather. So the next thing for us to do now is okay. I want to turn this one to zero. Write it out first, one, right? Then I ask you to write plus x, then open a bracket, right? Then equal to, our sole aim is to turn this one to zero, write zero. What are you going to put in this bracket? The first digit that you have up here. So always pray that most of the questions, this one should always pray that you should not have zero. If you have zero, that then there is a particular concept whereby you need to subtract root two from root one. Okay, but just take note, most of the questions you now have this one as zero. You don't have to be scared. Okay, so since I have two here, I will only relate it with the first digits. Only start from the top. Okay, the beginning, you always relate this one and the first one first. So I have it as two, right? So then I'll put the two here. Then I'll solve for x. If I solve for x here, what am I going to have? 2x is equals to minus 1 and x equals to minus half. So I'll now come here and use, okay, this one is on row what? Is on row 2, right? The formula now is row 2, then plus, what's my x? X is minus half. This row 2 is on what? This 2 is on row 1. So this is the formula I'm using. Okay, so that means, let me write out the matrix out again first. The matrix is 2 minus 1 3 1, 1 minus 8 6 8, 1 2 0 minus 2. So this particular row, now I wanted to turn this one to zero. So the operation I need to use now is, this is the row operation I need to use, which is row 2 then plus minus negative half of row 1. So this is the operation I want to work with, the row operation the row reduction operation I want to work with. Now that I have this now, the next thing for us to do, okay, is to go ahead and evaluate. So I want to start with this digit 1, this one that is there. So what is this one now is on row 2, 1, then plus minus half, related to the value of row 1, and that is 2, the corresponding value of row 1, and that is 2 cancel 2. If I evaluate this now, that will be 1 minus 1, that is 0. Successfully, I have it as 0. Do you know that I did not touch this first row at all? So I still have it as 2 minus 1, 3, 1. I'm only interested in this is only the operation I'm working with now. So I've already done the operation on this first digit in this second row, and I got it as 0. Now let's do the same thing for this position, minus 8. Row 2 for digit minus 8, then plus minus half, then row 1 is minus 1. I'll multiply it by minus 1. So if I solve this, what am I going to have? So looking at this trivially, I have this as minus 8, then minus times minus, that's plus. Okay, then that will be plus 1 over 2 times 1, that's 1 over 2. So if I find the LCM here, I have 2, I have minus 16, then plus 1, that's minus 15 over 2. So if I relate this and this together, okay, that is minus 8, then plus the x value, the row 1 value is minus 1. So if I evaluate this clearly, it is trivially seen that I will have minus 8 then plus 1 over 2. I'm trying to avoid any mistakes, so I will have it as minus 15 over 2. This is correct. Do you know that another person might decide to relate this row 2 and row 1? You still arrive at the same answer. So you don't need to be scared or anything. Okay? So I also need you to have one pattern to your solution. That's if you know you're using this method, follow it up. Don't swap it at all. So now I have the next digit as 6. So put 6 here, then plus minus half, okay, then times the digit for row 1. At this position, the digit for row 1 is 3. So I have this as 6 minus 3 over 2. So I want to use my calculator directly instead of looking for LCM to be on the safer side. So I'll just evaluate my calculator here. Just hold on, let me quickly compute that on my calculator for this adds. So this is what I have. So I want to express 6 minus 3 over 2. So I have calculator give me 9 over 2. So I'll put 9 over 2 here. Next is this 8 I'll have this as 8. Row 2 is 8 plus minus half times the value for row 1 is 1 at that point. So this is 8 minus 1 over 2. So what is 8 minus 1 over 2? Calculator also give me 15 over 2. That is what I got, 15 over 2. So then that is for the row 2. Successfully I've turned this one to 0. What's the next thing? The next thing is for me to turn this one here to 0, this one here. So I can't relate this one and this one again. Since this one has already turned to 0, I've already done my operation on this. That is, this one is gone totally. And now I have it as new row 2 here. So that means the only choice I have left is to relate this and this together. And to do that kind of, let me clean this off. Let me clear this off. So I hope you are following. It's not something that is really hard like that. So, and next thing for us to do here now is that I have row 2 here. This is gone, right? So I want to turn this one to 0. So you write it as 1 again, then plus x. I can only relate it with this first one, 2 equals to 0. You still have the same formula. This one is actually on row 3, right? It's actually on row 3. My x value, if you find x here, that's 2x equals to minus 1. I will still have it as minus half, which is done. So then this 2 here is actually on row 1. Okay, so the formula I'm using here now is also something similar to the first, to the second one. That's row 3 plus minus half of row 1. So now let's try that. Let's try to do the operations. For this first one, I have 1, then plus minus half. At position row 1, I have 2. So if 2 cancel 2, I'll have 1 minus 1. The result is 0. So successfully, this one will turn to 0 with the help of these row operations. Now I have 2 here, right? So for the next digit, I have to write out 2, then plus. I'm following this formula, okay? Minus half. So what's the row 1 value at this position? That's minus 1. So that's 2 plus half. So what's 2 plus half? That should be 5 over 2. That should be 5 over 2. So I have it as 5 over 2. Now let's try this one. 0. So this is 0, then plus, I'm still using that formula, 1 over 2, then times the corresponding digit for row 2, row 1 rather, that's 3. So trivially, this is just 0 minus 3 over 2, and that's minus 3 over 2. I already have this as minus 3 over 2. I hope you are following. So that aside, so the last one is minus 2. I have minus 2, then plus minus half, then the corresponding value for row 1, that is 1 in that case. So I have this as minus 2 minus half. So what's minus 2 minus half? On calculator, you have it as minus 5 over 2. So successfully, I noticed that, okay, this is my main target. First digit, cross out the left to right diagonal. So I need to turn the digit I have below this line. I need to turn everything to 0. So I noticed that this is 0, this is 0. So the only thing left now is just this 5 over 2. So I believe you can actually get that now. So I need to turn this 5 over 2 to 0. What are you going to do? Use the same that pattern I used to give. So that's what I'm going to use it. So I believe you can actually understand it clearly for me. So this is where that my pattern used to work most of the time. When you have fractions, then when you have fractions, you don't know what to do most of the time when it comes to row reduction formula, something like that. So if you use that particular form, that general formula I formulate earlier, make sure you get it clearly. You even without any mistake. So now let's check. I also turn this one to 0. Write it out first. 5 over 2. Then plus x, right? Then open a bracket. Our sole limit is to turn it to 0. So I said you can't relate this row and this first one. Why? Because if you relate 0 and 2, it will affect this 0. So I can only relate this row, this last row, this one here that was not 0 with this second one, so that this 0 and 0 will not affect. So that's just the concept. So that means the only thing the value I'm going to put in this bracket now is this corresponding row 2 value, which is minus 15 over 2. So I need to solve for x. Calculator can do this for you, but if you want to solve it, no problem. To solve for x now, it is advisable to find the LCM. The LCM of 2 and 2 is 2. Multiply this one by 2, this one by 2. Multiply everything by 2. Or you do it anyway, you can actually, just normal find x now, so you can do that. If I multiply this one by 2, I'll be left with 5. If I multiply this 10 by 2, 2 will cancel 2, I'll be left with minus 15. Then 0 times 2, I'll be left with 0. So if I find x here, that is 15x is equals to 5. If this one goes like this, or you say, okay, minus 15x is equals to 5, minus 15x is equals to minus 5, rather, if this one goes like this. And if I divide both sides by minus 15, minus cancel minus, that's 1 over 3. So my x is 1 over 3. So let me clear that off. I want to manage the space. So if I look for x now, this my x value is 1 over 3. So this 5 over 2 is on row what? Is on row 3. Then the x value I got now is 1 over 3. This minus 15 over 2 is on row 2. So I think this is the row operation I need to use. So just write it out. This one now I need to work on row 3 plus 1 over 3. This is general formula I need to follow times row 2. So now let's start. For this 0, I'll have 0. For this particular 0 here, I have 0. Then plus 1 over 3 times row 2, corresponding value for row 2 is 0. So that's 0 plus 0, that's 0. So I still have it as 0. So I did not touch, I don't have any business with this first row. I don't have any business with the second row. The only operation I want to work with is this third row. And at 0, I still have it at 0. That's what I did now. Okay. So at 5 over 2, let's check. 5 over 2. Root 3 is 5 over 2 plus 1 over 3 times root 2, corresponding value for root 2 is minus 15 over 2. So let's check minus 15 over 2. So 3 here 1, 3 here 5. So it seems I have 5 over 2 minus 5 over 2. And that is 0 as well. Successfully, you see, it worked. This thing, it used to work most of the time. Just get used to it. That's all. So then I have minus 3 over 2 here. So what am I going to do? At this position here, write minus 3 over 2. Write it out. Then plus, okay, I have 1 over 3. Then times what? The corresponding root 2 value. That is 9 over 2. So now let's check. What are we going to have? 3 here 1, 3 here 3. So I have minus 3 over 2 plus 3 over 2 is 0. It seems everything wants to turn to 0, so that the rank will now become 2. The rank, I'm very sure if this last one did not give us 0, that means everything here is a non-zero. But let's confirm. Let's check. Let's try the last one. I have minus 5 over 2 here. Then plus 1 over 3. At this position, my row 3 value is minus 5 over 2. My row 2, the corresponding value for row 2 is 15 over 2. So let's check. I think that will also give us 0. 3 here 1, 3 here 5. Minus 5 over 2 plus 5 over 2. That's also 0. So I also have it as 0. So what's our rank? Our rank of matrix A for that linear map phi, our rank of A is the numbers. How many number of non-zeros do you have in that matrix after after reducing it to rational form? Is the number of non-zero rows. And if you count the non-zero rows, this is one non-zero rows, these are other non-zero rows, but this is zero row. This is a zero row. Okay, this is a non-zero row. A zero row is the row that actually has all its digits as zeros. So this is also another non-zero. So how many non-zero rows do you have? Just two. So the rank of that question B is also 2 as well. What if you have a 4 by 4 matrix? Let's say you have something like this: 5, 2, 6, minus 1. Let's say you reduce a matrix to rational form of this format. This one is 0, 0, 0. This one is 0, minus 1, 4, 2. So what will be the rank of this kind of matrix? Let's say this one is 0. So what will be the rank of this matrix? You just see, okay, this one is 0, this one is gone. So this is non-zero, non-zero, non-zero. So the rank of this matrix is 3. So there's nothing special about rank of matrix. So that's how it works. That's how that one works. So I believe I've tried my possible best to explain this topic to you. So this is done. So we need to move straight to bilinear form and quadratic form. So that's the next thing to do. So I don't need to create another video series for that. So let me just quickly bring that in here. So I have bilinear form. This is the next topic. I don't want to use this. I don't want to use this pen. So the next thing for us to consider is a bilinear form, bilinear and quadratic form. That's the next thing we need to consider here, right? So how does it work? Okay, let's see how the questions comes. So in this bilinear form now, actually by something that is linear, you know what that means. So let's say we now have, let's say we have a question which says, let me just look for a particular question here. Let me just look for one question. Let me look for one question. Okay, I think I've seen one. So this question comes in this manner. It says, let u equals to x1, x2, x3. This is u. And we also have another one again, another vector space v as y1, y2, y3. Okay, so that means I have two vector spaces here, u and v, right? So we now have a definition that says, okay, let's say you have a linear map in phi, a linear map phi in terms of u and v that picks this u and v together. So the definition given to us for it. So I think this will be enough for that. So let this linear map u and v be equals to. So now let's see, check it out. We have this as 3x1, y1, sorry, that's minus. We have this as minus 2x1, y2, followed by plus 5x2, y1, followed by plus 7x2, y2, followed by minus 8x2, y3, followed by plus 4x3, y2, followed by minus x3, y3. So now the question now says where phi, okay, phi is not a linear map. Phi is just a matrix, just a matrix notation in this case. Just a matrix notation. So what do you want to? Okay, let's just say the question exactly says express express phi in a matrix notation. Sorry for that. That's the question. How can you express phi in a matrix notation? Okay, I believe you are familiar with the way we used to do it now. Looking at this, I have 3x, you just everything here. I didn't mean I have it in comma form. Like this one comma, this one comma. I can easily find the matrix of, I can easily express this file in matrix form. But now it's different entirely. It does not really look exactly like the linear map form. So the since we don't have the image of something of this nature, I don't have the image that will really work here. And I don't have any comma here. So I already have everything here. So to find the matrix phi of u and v in matrix form, okay, whatever you have to do now in this case, the formula is always equals to, when you have something like, there's a definition for bilinear form. The reason why this is bilinear is that if you look at all this expression here, they are all linear. X1, y1, no square. There is no square at all. So they are all in linear form. Okay, they are all in linear. And the bi simply implies that the two, this bi means you have two variables at the same time and they are all linear. That's why we have it as bilinear. And as for quadratic, I'm very sure, as for quadratic, you usually have like something like x1 square. You have square on it. So when we get to quadratic, example on that quadratic, you understand it clearly. Now looking at this now, I have 3x1, y1. I have minus 2x1, y2. So to look for the matrix notation of this, according to definition, there's a proposition for this too that says the answer to this in matrix notation form, you always have a vector x, take the transpose. Okay, you always have a vector x in column form, you take the transpose. Then you always multiply it by matrix A. How do you get matrix A? I will explain. And then you always have vector y. Then that's all. When I say vector x, do you know what vector x means? A vector x is always in column form. Vector is always in column form. Okay, in column matrix. Alright then. A column vector x is always, okay, I'll use small letter x1, x2, x3. Okay. What of a column vector y? This x is a column vector x. This is a column vector y. Take note. And y now will now be small letter y1, y2, y3. So there's a proposition that says that if you want to express phi of u and v, Okay, in matrix notation, this is this proposition. So whereby my x transpose now will now be the transpose of, if you want to look for transpose of this, x is already x1, x2, x3. So what's the x transpose? That's the vertical becomes horizontal. That will be x1, x2, then x3. Just put comma there. Or you don't need to put comma rather, since it's a matrix, since it's a matrix. So I'm not using comma in that case, no. Don't use comma, please. So x transpose now will just be x1. Taking that my x is in column form. So if you now take the transpose, I will have it as x1. The second digit will be x2. This one will be x3. But I don't know what my matrix A is. Your matrix A, you have to get it from here. And I will explain that as well. So my vector y now will be y1, y2, y3. This is the final answer. But you can't leave it as this because we still need to find matrix A. So how do you find matrix A? We are only considering the coefficient of, let me write this clearly. To get this matrix A now, let's open a bracket. You are only going to, there is, I think there is a pattern for this too, whereby you are only considering the coefficient of, how do you used to write it? Okay, let's start with x1, y1. Okay, let's start with x1, y1. This is the coefficient. Please take note. Use the coefficient. This second one here will be x1, y2. Please take note. And why am I using x1 up to x3? Because sometimes I can also have x1, x2, because I'm using x1 to x3 because of what I have here. So this u now is equals to capital X. Okay, this v now, this x transpose, this v now is, okay, this is just, no. This is not a matrix form, this is in vector form. This is vector space since there's a comma. There's a comma. But I actually use this x1 up to x3 because of this, what's what I saw here. Okay, and what's of what I have here. That's why I use x1 to x3. I didn't mean you actually have x1, x2, x3, x4. Then you must make sure that this one has up to x1, x2, x3, x4. And then your matrix A now, you now have x1, y1, x1 for everything here. So you just have y1, y2, y3, y4 in that case. To your standard logic. Then the second one will now be x2, y1, x2, y2, x2, y3, x2, y4. That is if you have this one from x1 to x4. Then the next one will now be x3, y1, x3, y2, x3, y3, x3, y4. Is that where you're going to stop? No, because you still have to use x4 also. X4, y1. So that's just the pattern. So what you need is just the coefficient. Please take note. So this one will now be x1, y3. So what will be the next one? X2, y1, x2, y2, x2, y3. What's the next one? X3, y1. I'll stop at x3 since the highest thing I have here is x3. X3, y2, and x3, y3. So what are the coefficients? It's only the coefficient I need. Okay, so my final answer in matrix notation form is x1, x2, x3 times, what's my vector? A now. So I have to look for this now. What's coefficient of, I said I need the coefficient. What's coefficient of x1, y1? That's what I need. Let me use another color for that. Coefficient of x1, y1. Let's go and check. See it here. All these things like this is what I actually have here. I'll just write it as 3x1. This one is minus 2 x1 y2. While this one is what? Okay, you know what that means. So I don't want to use it here, but just take note that this is how the arrangement looks like. So don't let us insert it. Don't let us insert it. Okay. Here I have x1 y1. The coefficient is 3, so I'll write 3 here. X1 y2. I don't know. Is there any way I can reduce it here? I can reduce it this way. So just my, I don't know that you can see it while you watch, but just look at what I write. X1 y1 now, the coefficient is 3, so I'll write 3 here. X1 y2, let's look for it. X1 y2. We don't have x1. We don't have x1 y2 in that case. We don't. So looking at it now, let's quickly check. Let's quickly check. X1 y2. I think we have x1 y2. See it here, minus 2. Good. Okay. And we need x1 y3. Do you have x1 y3? No, that is 0. Do we have x2 y1? Yes, 5. Do we have x2 y2? Let's check. Do we have x2, y2? Yes, that's 7. X2, y3, that's minus 8, as you can see. And what else again? X3, y1, we don't have x3, y1, 0. X3, y2, we have 4. X3, y2, we have 4. And x3, y3, we have minus 1. So in matrix form, this is what we are going to have. So let me help you zoom it back. I believe you can see it clearly now. So when you do that, this is what you're going to have. So this is the matrix notation form. This is the matrix form. And this is the final answer. This is the matrix form of phi of UV. So please, this is how it works. So that's the matrix form. But now let's try to solve question on bilinear form. Now let's solve question. That's just a simple thing that way. So but let's try to solve question and see how it works. And let's see how it works. So let's consider this question that is there, which says let phi be the linear form case. Phi is a bilinear form in this case, not linear map now. Let phi be a bilinear form of vector space R2. Okay, that's a 2 by 2. That would be a 2 by 2 matrix in that case. Defined by, so it is being defined by, let me write it down there. Phi of, now we are using x1, x2, then comma. So I have to write that very well. Okay, it's been defined by x1, x2, x1, comma, x2 in this case, and I also have y1, y2 in this case. So it is equal to, we have it as 2x1, y1 minus 3x1, y2, then plus x2, y2. I believe if I ask to look for if I have, in this case, if I ask to look for matrix A, the matrix notation for phi, you can, or if I ask to look for matrix A, you can actually do that. Matrix A now will be, you know, I only have, this is my U, this is my V. So my matrix A now will be, I notice I have x1, x2. So in this case now, the general form of matrix A now will be x1, y1, abi, then x1, y2. That's all. I can't have y3 since y3 does not appear in this image at all. So then the next thing is to have x2, y1, x2, y2. So my matrix A here now, I've not started the solution, I'm just trying to explain. So what's the coefficient of x1, y1? 2. This one will be 2. This one will be minus 3. x2, y2. So x2, y1. No x2, y1. 0. x2, y2. 1. So this is my matrix A. What if I ask to look for the matrix notation? You know what that means? Hey. But let's look at the question. So I've not seen any question here. They now say find. So let's see what we want to find there. What do we want to find? I find the matrix A. Wow, that's interesting. I've done that already. Find the matrix A of phi. I think I've done that. But they were not given, they have given us a point. Find the matrix A of phi, given the basis. They now give us the values for, they gave us this value initially. They gave us values to use, please. So you need to be very careful. So let's check. Given the basis, they give us a base. Given the basis, that's what they give us now. They give us u1 equals to 1 comma 0, and u2 is given to us as 1 comma 1. So I think this u2 should simply represent our v. So that means to be on the safer side, I want to change the question to v so that you don't get confused. If you know you want to use what is in the material u1, u2, that means this one will be u1, you call this one u2. But I don't want to use that. I think v is better so that you understand it clearly. So that's for that. So that means I don't need to go through these steps. I also, okay, this is one. They've already given us the result for x1, x2, right? They're already giving us x1, x2, 1, 0. So I'll know what to do in that case. If I have 1, 0 here now, so I will look for how to go about it in this case to find matrix A. But let me write out all the questions first. Another question, that's why we should look for another matrix again. Look for another matrix B of that same bilinear form given the basis. Given the basis. This time around, okay, please take note of this is u1, u2. Let's see use u1, u2. I think that's what is given. But in this second part now, we are now given v1, v2. V1. I think I understand the concept now. 1 comma minus 1. These are like, I can use UV here, and for this second matrix I can still use UV. Okay, they just want to make it a different form. In this question 1, this question 2. That's why they use U1, U2, V1, V2. I can use UV for the first question. This second one I can still use UV. So as far this, okay. So now looking at this expression here, now what am I going to do? So that's not all. Let's look for the third questions. Look for the transition matrix also as well. Look for the transition matrix from basis UI to the basis VI. I represents from 1 to 2 because I only have the highest is I is 1, I is 2. I is the maximum for I is 2 in that case. And at the same time, the fourth question now says show that B is equals to P transpose of AP. Remember this formula now? I think we've used something like that before. So now let's try to find a way around this. To look for matrix A now, okay? To look for this matrix A of the bilinear form of phi given this basis U1 and U U2, right? So we have U1 and U2. How are you going to look for the phi of U1? The phi of U1 is, okay, simply implies I have 1, I have 0. I have 1, I have 0. So what is 1 comma 0? That's just a point that we actually have there. But one thing is, this aside, under this bilinear form of this, we always have our matrix A to be equals to A11, A12, it's a 2 by 2 matrix now since it's been defined by R2. Remember, R2. If it's R3, I'll use 3 by 3. If it's alpha, I'll use 4 by 4. So I'll have A11, A12, A21, A22. Okay? So for A11, at A11, all these things are proposition. Go and check the theorems, most of the propositions that are there. So at A11, we always have our expression as phi of U1 comma U1. Please take note. And at A12, we always have our phi as, okay, this is U1, U1. What is the second way to be? U1, U2. Do you standard logic? And this A13 now will be phi of, I've used U1, U1. So I think the next one now is now go straight to U2, U2. Then this one will be U2, U1. And this last one will be U2, U2. That is just, this is A21, this is A22. So how are you going to get this result now? So this phi is for U1 comma U1, right? U1 comma U1, which simply implies that this definition here. So I think if I've not labeled that, I will have something of this nature. Phi of, what is U1? U1 is given to us as what? 1 comma 0. So you have to be very careful there. And U2, U1 as well. Yeah, I was also using U1 as well again. U1 is still what? Let's check. I still have U1. U1 given to me is still 1 comma 0. So what is this going to give us? It means my x1 is 1, my x2 is 0, my y1 is 1, my y2 is 0. So substitute it here and then get a final answer. That's all. So my x1 now is 1. I'll put 1 here. Okay. My x2 is 0. This one is 0. My y1 is 1. My y1 is 1. My y2 is 0. So if I do the multiplication now, that's 2 times 1 times 1. That is 2. So I have 2. Then minus 3 times 1 times 0. 0 times anything here, that is 0. So I have minus 0. Then plus 0 times y2, that's plus 0. So the final answer here is just 2. So you do the same thing for this one too, one after the other that way without doing any mistake. Okay, U1 is 1 comma 0. U2 is given to us as what? Let's check. 1 comma 1. 1 comma 1. This is standard logic. So what will this one give us? That means this simply implies that I will relate it with this. with this expression here. That is my x1 is 1, my x2 is 0, my y1 is 1, my y2 is 1. So now let's substitute them here. That will be 2. X1 now is 1. That's 2 times 1 times 0. This one will become 0. This one is 1. Y2 is 1. That's minus 3. X2 is 0. This is so I have minus 3 left here. But let's try to check again. Let's try and check again. I have 1 comma 0 and I have 1 comma 1 as my u2. So let's check from here. This is 2. I don't know. Let me create a worksheet for that. 2 times. This is my x1, 1. Then times y1, 0. Right? Then minus 3 times my x1. My x1 is 1, right? And my y2 is 1. This is x1, x2 is 1. Okay, my x2 is 0 in this case, right? So then followed by plus my x2, okay, my x2 here is 0 times my y2 is 1. So this will become 0. This I will be left with minus 3. So is minus 3. Please take note. And the next thing for us to do now is what else again? What else do you have to do? U2, U1. So we have U2, U1. So let's confirm this. Are you sure this is no? This is not 0. This is x1, y1. Y1 is 1. Sorry for that, please. Omo, we need to be very careful. This is 2 times 1 times 1. That's 2. 2 minus 3. That's minus 1. Here, this is minus 1. So if you do the same thing for this one too, this phi of U2 is 1 comma 1 and U1 is 1 comma 0. So you have to be very, very careful here, seriously speaking. So if you substitute it into that expression, then you have this one as 2. And if you do the last one as 1 comma 1 and 1 comma 1 in that case, you have this one as, if you substitute that, you have 0. So that means my matrix, the matrix A I'm looking for when basis is given. If basis is given, please use this formula here, use this expression. Okay. What if you now have a what if it's now 3 by 3? I think that's proposition 2 is in that chain. Go and check the material, you see it there. So just follow it up. If I'm very sure that if it is 3 by 3, okay, are you still going to have U1, U1, U1? So then that is going to give you a very lot of stress. I can still make another video on that sha. A11 now, I already have it as I got 2. 2 minus 0, I got 2. My A12, I got minus 1. My A21, I got 2. And my A22, I got 0. So that is what which is A. So you do this the same thing similarly to B also, to find B also. Because that's why I said you can use UV. You can use UV here too. But it's just that they want this, the representation here to be different from this. That's why they use V1. So I'm still using the same formula to get matrix B. Now to get matrix B now, to get matrix B, I'll still use A11, A12, A21, A22 such that my A11 is equals to the phi of, this case I'm using V. We are given V1 and V2. So that means this one will now be V1 comma V1. Okay, I'm still using the same pattern. This one will now be V1 comma V2, right? The third one will be what? This is A12, this is A13, this is A14. So this one will now be V2, V1. Do you remember that logic? V2, V2. Then you substitute also as well. What's your V1, V1? V1 is given to us as 2, 1, 2, 1. V2 is minus 1, 1, if I'm not mistaken. Let's check. 1 comma minus 1, sorry for that. That's 1 comma minus 1. That's what we have. So you know what to do in this case. You now have to substitute. This is my x1, x2, y1, y2. Substitute it into this expression here. And then whatever you get, put the result here. So if you do that, you will get this one as 3. If you do the same thing here, my v1 is 2, 1. My v2 is 1. Sorry, this is v1, v1. I'll still have 2, 1. Sorry for that, please. So this one is v2, that's 1, minus 1, please. So this one will now be v2 is 1, minus 1. Then v1 is 2, 1. While this one will still be 1, minus 1, and my v2 is also 1, minus 1. So when you try to simplify all this now, this will give you 3, this one will give us 9, this one will give us 0, and this one will give us 6 for time's sake. So that's what we're going to have. So that means my matrix B now is simply 3906. This is my A11, A12. Please take note of. It's not something that is really hard. It's just so simple. I take it as I see this thing as quantitative reasoning. So it's not something that is really hard like that. So now, what are we going to look for now? The third part, I think that's where we are. They said the transition matrix from basis U1 to what? Basis V UI to base VI. Okay? UI to VI. So I think there should be a proposition for that too. Okay? Normally, we always VI now implies that we have V1, we have V2, right? So for V1, what are we going to have in that case? And always think there's a position that says that you want to look for from UI to, let's check again. Let's check the question again. It says from basis UI to base VI in that case. Now, for this V1, remember that V1 is given to us as 2, 1, and V2 is given to us as what? Minus 1, 1. That is for VI. I read these two. So at this V1, we always have this. There's a position that says V1 it will be equals to, we want to find, what do you want to find? So let's check again. Transition matrix from UI to basis VI, right? So from that, you have to equate this one to the addition of UI, the UI value, that's U1 plus U2. Okay, while this, okay, will just be equivalent to, let's just say, you can actually have this as twice of U1 minus U2. So what I just noticed here is that I noticed that we have this coefficient as 1, this is 1, this is 2, this is minus 1. Let's check the basis given to us for U. U is given to us as 1, 0, 1, 1, right? I have 2, 1, I have 1 minus 1, 2, I have 2, 1 here, okay, I have 2 minus 1, and then I have 1, 1. Relating this first and last, first and last, right? So look at this now. We have the 2 and minus 1, that first and last, and the 1, 1 itself in that case. So when you have this expression here, whatever you have as the coefficient in this case now, whatever you have as the coefficient in this case, that's 1, 1. Will automatically give us the transition matrix. And I think the transition matrix is, that should be PT that we are looking for. I think my PT here, whatever that appears as the coefficient here now, I can see 1 here, 1, 1, 1, 2, minus 1. Okay, that's what I actually have here in that case. And this is my PT. So the transition matrix P now, let's check what is going to be our P. P is going to be the transpose of this one again. So 1, 1 comes vertically here. Then this becomes 2 minus 1. So I've already gotten my PT and P. So we've gotten the transition matrix in that case. So that is for that. And then they ask us to show that matrix B that we got is equivalent to the PT of AP. Is that true? What's my PT? I got my PT. I think the result is here. PT is, we have our PT as 1, 1, 2 minus 1. Then our matrix A is what? 2, 2 minus 1, 0. 2, 2 minus 1, 0. And our matrix P is 1, 2, 1 minus 1. So if I multiply all this together, if this multiply this and this multiply this, if I multiply all this together, you surely get P back. You can try it out. You have it as 3906. So that's just how this works in that case. And that's all for bilinear form. Okay, that's all for bilinear form. But we also have another thing entirely, which is quadratic. The quadratic form. How does quadratic forms look like? As I said, I'm going to explain this thing completely in this video. So for quadratic form, how does it looks like? For quadratic form, okay, I notice that there's a question here which says in how to, okay, consider this quadratic form. Consider the quadratic form of we use q of x comma y to represent that. Okay, you know it's how to now, so I'll have x comma y here, and the definition is c. In this case now, see what we have now. And you see we are now having a quadratic, we are having a degree of highest degree of 2 on any of the variables. So this is a quadratic form. This is how it looks like. If it's linear form, this is by linear form, you not say anything like square at all. So what that has to do, then I say find the matrix of what the quadratic form q and find its signature. Please take note. If you want to find signature, there's a formula to find signature. Signature is actually equals to find the signature, the formula is equals to consider that matrix and count the number of positive value that you have. Count the number of positive value you have minus count the number of negative values that you have. So if you have a matrix, let's say you have a matrix 2, 5, 6, minus 1. So what's the signature of this matrix? That's count how many positive value do you have here? 3. How many negative value do you have here? 1. So the signature is 2. I've given you a clear picture of what signature means. So how do you look for matrix Q? You know, that's how do you deal with something like this. So look for matrix Q is not something that is really like that. So I think there should also be a format to get the matrix for Q in that case. Now you notice that here now there should be another proposition for that. I notice in this case now I can actually have the pattern for the matrix for Q. Okay, there should be a pattern for the matrix for Q in this case. Let's say I want to find the matrix. Let the matrix of that Q of x comma y that I'm looking for. You know, I want to look for the matrix form of that this Q x comma y. So that's matrix A. So in this case now, it's just as if I'm trying to look for um, the x squared, coefficient of x squared, coefficient of the first xy, coefficient of the yx, and coefficient of the y squared itself. So if I look at this clearly now, it is not well arranged in this case. What if I have, okay, x squared there? Then I must have a 2 by 2 matrix. I must have a 2 by 2 matrix. So if this one represents x squared, right? What am I going to have in this case? Here will be x, y for this kind of question. This is x, y. This should be another x. Okay, let's say we have x, y. Then I think towards this line here, if I have x square here, this one should be y square. Okay, so if I have x, y here, I've used x, y. So do I have any other thing to use? No. I think this I can decide to use this as still yx to xy then yx. So if I have yx in this case, this is still something as xy. That means I'll just come here and deduce this as minus 6xy minus 6xy then plus 5y squared. So this will now be equivalent to what's the coefficient of x squared? That's 2. Coefficient of xy minus 6. Luckily for me also, I also have xy here as what? This also minus 6 and this also 5. So I think that matrix for A now is gotten as 2 minus 6. Add this as minus 6, then 5. I think this is sorted out. So to now look for its signature, we need to, before you can look for signature, you need to make sure that you express this matrix to a row echelon form. So before you can actually consider, just like we find rank, but we are not looking for rank, we're looking for signature. To find the signature, you need to express this thing in row echelon form. So that means you pick this first digit and then cross out the left right diagonal. Any numbers that appears below this, you must make sure that you turn it to 0. So I want to turn this minus 6 to 0. So use that formula that I said. I want to turn this minus 6 to 0, write that minus 6 out. Then plus x, then times something equals to, our main objective is to turn it to 0. So I can only insert 2 into this place and then solve for x. If I solve for x here, I will have 2x is equals to 6 and my x is equals to 1 over 3. So that means this minus 6 is on row 3, is on row 3. Then my x is 3 divided by 2. That's 3, abi? My x is 3 if I solve it out. My x is 3. Then times this 2 is on row 1. So the formula I'm using basically here is row 3 plus 3 row 1. That's the formula I'm using. So what's now going to be our matrix A in red echelon form? So that means I did not touch the first part. I only want to deduce this. So I'm very sure this one will give us 0. So this 5, this 5, not am I going to have? That will be 5 plus 3 times row 1. What's row 1? Minus 6. And that will be 5 minus 18. And that's minus 13. This is minus 13. Okay. Now that you have it in real echelon form, so what will be our signature? Signature now will now be equal to signature will be equals to the number of positive sign. Let me put positive like so you remember. Then minus the number of what? Negative sign. Like yeah. So the number of positive that I have here is just okay. Sorry, is this minus 6? This is not minus 6. What am I doing? This is not minus 6. This is 6 now. Okay. I think that should be the opposite. I have to take negative of the 2. I have minus 6x. Minus 6x. Yeah, that's what I have. So this is 5 plus 3 times minus, that's minus 13. I'm trying to look at what I have here. So we are not considering this. We're not considering what we have here. Okay, when you get to this point, this is not where you are going to pick the simulation from. Hey, I want to try to recall that again. So when you get to this point here, okay, you need an augmented matrix before you start this ratio. So let's start that again. Recall that. Forget about what we have done so far. Let's try to solve it correctly. Recall that my matrix A is 2 minus 6, and then 5. So you need to form an augmented matrix for this. When I say augmented matrix, that means I want my A to be equals to 2 minus 6 5. So then you separate it, and here this case you put an identity matrix here. An identity matrix AI is equals to A. Doing that A is still equals to A times identity matrix. Yeah, they are equal. So times, not minus. So if I can actually mix the augmented matrix, will just be the combination of this matrix here and that of 1 1 0 0. That's for the 2 by 2. So that particular operation that I wanted to apply here, which was row 3 plus 3 row 1. So I'll do it for everything. It's going to be applied to everything. So that means in this case now I should have my A to be equals to my augmented matrix rather. My augmented matrix will now be of this form. I did not touch this one at all. But this down part is what I did. This one gave us 0. And this 5, well, after doing 5 plus 3 times minus 6, this position, I have it as 13. So now let's do the same for this one. 0 plus 3 times row 1. Okay, and that will give us 3. And this one is 1 plus 3 times 0 in that case. And that is what? That is 1. Do you understand that logic? So when I now get to this point, whatever I have here now, whatever I get here now is my P transpose. So my PT is actually 1301 for that case. So what's now the value for P? If PT is this, what's the value for P? My P now will be the transpose of this one. That's 1301. Now I have 1031. I have 1301. Right, this is my PT, this is my P, and I already have my matrix A. Right? So that means the diagonalized matrix I'm looking for, that cube that I'm looking for. In fact, this is just the steps is to find your matrix A, and I believe you know how to do that. How can you express this definition? How can you express this definition in matrix A? So that's what we have here. Minus 6 minus 6 is minus 12xy. Okay, then I have 2 and 5 here. I know what to do. Form an augmented matrix and make sure that you have this in row echelon form. That's just the difference. So when you have been able to do that, whatever you have on this right hand side there, is your PT. So you can easily find your P. So therefore, the Q now, the matrix Q that we are looking for, eh, is actually equal to, remember that formula that we always write as PT of A of B. So remember this. So I will now have to multiply this 1 0 3 1 by the matrix A I got as 2 minus, what was that thing? Minus 6 5. Multiply it with this matrix 3 0 1. So when you multiply this all together, when you multiply this and this, you will now have it as 2 0 0 minus 2. Please take note, when you multiply this, this is what you get. So then after you've now gotten the matrix, this is matrix for Q that they asked for. Where's the question said? Find the matrix of Qx of Q and find the signature. So the matrix of Q is actually equal to this result, and that is what we have here. So when you now get to this point, what is now the signature? Signature now is equals to the number of positive values in this Q and the number of what? Negative value that you have. And that is number of positives here. There are how many? Number of positive value aside from these zeros. Aside from these zeros, what do you think? Aside from these zeros, I only have two. I only have one here, one positive minus how many negative? One negative value. So the signature here is what? Is 0. Okay, that's just how it works for that. But what if that is it? I have two zeros here. But there's another format whereby if I want to give another matrix, what if I give you any matrix and I ask you to look for the signature? Will you be able to do that? So let me just give one more. Let me just look for one matrix to formulate, and then from there we will end this explanation. I think I'll try my possible best to explain rank of matrix, bilinear form, and this one that I just did here now is the what? Is the quadratic form. I think I'll try my possible best to explain that. So to look for signatures, all these signatures and the likes, let's say I want to look for a particular matrix and then you just state the signature for it. I don't know whether I have any example. Yes, I have an example here. I've seen one here whereby after looking for this PTAP in that question, I now have something of this. This is what I have left in that question. I actually have 1 0 0. Let's say we now have 0 minus 2 1. We have minus 10 minus 7 1. Please, when you get to this point, so I think I've understand the concept. The signature here now, we are only considering the left right diagonal and then count the number of positive and negative that you have. Please take note. So I'm not considering all these zeros or all these ones that are here. Just the left right diagonal. Please take note. Whereby I have 1, I have 1. So how many positive? I have 1 minus 2 1. So how many positive value? 2. How many negative value along this line? 1. So the signature here is what? 1. This is one example that I saw somewhere. So please take note. Take note. Take note of this. So the signature is 1 in that case. So that's how all this thing works for that. Okay, that's how it works. That's how it works. So I think this is where we are going to end this video for now. Thanks for watching.